Today, as you can see, we will be talking about how to find the volume of a sphere. And unlike in the past, where I just gave you the formula for solving it, today we're going to try to discover this formula in a similar way to how it was discovered in the past by Archimedes. Now, in order to do that, we're going to have to rely on a lot of algebra. So we're going to review some of those algebraic concepts first to make finding this formula and simplifying it a little bit easier. Here's our first algebra review. How do we simplify this mess? Now, the first thing that you have to remember is that in algebra, you're allowed to move around multiplication provided everything that you're moving is all being multiplied together. So for instance, I can, since this is all multiplication, multiply the 5 times the 4 first, or I could multiply the x times the 4 first, or I could multiply the x cubed times the 2/3 first. It's really up to me. So let's go with how to multiply this in as easy of a way as possible. And I'm going to start by just taking all the numbers that are normal numbers and multiplying those together. So that would be 5 times my 4 times my 2/3. And I'm going to take my variables and I'm going to multiply those together since we typically like our numbers before our variables. So that's going to be a multiplication of x times x cubed. With this, what I'm going to do next is I'm going to take my 5 times 4 times 2/3 and I'm going to simplify that. Well, 5 times 4 I know is 20. 2/3 can be hard to multiply by. We want to often switch this to a decimal, which is 0.6 repeating. The problem with doing that, though, is you lose a lot of accuracy in your formula the second you get a fraction that does not make a perfect decimal, like 0.5 or 0.2. So what we're going to do is we're going to try to keep this a fraction. Now I can multiply 20 times 2/3, and that just comes to the rules of multiplication with fractions. So we know that 20 is the same as 20 divided by 1, since the division by 1 doesn't actually change the number 20. And when you're multiplying fractions, all you need to do is multiply across the numerator, the top, and multiply across the denominator, the bottom. That gives us 20 times 2, which is 40, over 1 times 3, which is 3. So we have a mess of 5 times 4 times 2/3 simplified into 40 over 3. And I do personally like top-heavy fractions, so I'm actually going to leave it as a 40 over 3. Our next one is how do I simplify this? Because yeah, I've simplified my normal numbers, but I still have these x's, and if we can combine them, it would be great. Well, if this was addition, we'd actually be stuck. We could not combine them. But thanks to the fact that it is multiplication, well, just remember what x and x to the third means. X just means we have a number that we don't know. And x to the third just says that we took the number and we multiplied that x times itself 3 times. So I'm just writing this down as it actually is in the long form. Now here, because I can multiply in any order I want, I don't actually need these parentheses. So I'd have x times x times x times x. And that is just saying I'm going to do x times itself 4 times, which is the same as x to the 4th power. And you might notice that all we did is we took our original exponent of x to the 1, and we added to that the exponent of 3 to get an overall x to the 1 plus 3, or x to the 4th. So that's our first algebra review. Let's move on to our second. Our second is how do I do simplification when my terms look like this? Well, first off, your terms should not look like this. Anytime that you can organize things, please do. It will make your life a lot easier and help you recognize patterns. So when I look at this, I see 12xy, which is typically how we see something. But this term 4 and y and x is a bit of a jumbled mess. Remember that we like to keep the numbers out front, and then we like to go in alphabetical order when it comes to the variables. So that would give me a 4xy. And I can drop the rest of the problem around this. So I've got 12xy minus 4xy. Some of you guys might have just noticed the pattern. Notice here we're talking about having 12 of these xy's, and we're talking about having 4 of these xy's. So what I'm saying is I had 12, I'm taking away 4, How many of these xy's do I have? Well, that is just 12 minus 4 to give me a total of 8, and then our xy's, which remain unchanged. So I've got 8 of these xy's. And so that's how I can simplify these. I start by organizing it, and then I remember that as long as these two are the same, these are the same, xy, I can combine them using just their coefficients, that number in front, to get a simplified version. The third thing that we're going to remember is how to add or subtract using fractions. And the key to this is you can only add or subtract if your denominators, or the bottom of the fraction, is the same. Now currently this number 3 doesn't even have a visible denominator. So what we're going to do is we're going to give 3 a new denominator. And we really want this denominator to be the same as 6. So I have to say, how can I write the number 3 so that it's divided by 6? Well, here's how you do that. You're going to take 3 times 6, which gives you an answer of 18, and put that over 6. The reason why we can do that is, well, 18 divided by 6 gives me 3 back as an answer. So now I have 18 over 6, and I'm going to subtract from that 5 6. Well, this is where addition and subtraction isn't so bad, because as long as we have the same denominator, what we can do is we can subtract across the numerator, the top of this fraction. So I'm going to do 18 minus 5 to give me 13. And your denominator, the bottom, is going to stay the same. So I end up with 13 over 6. If you want to simplify that, you can do, how many 6's go into 13? Well, 2, and I'd have a remainder of 1, because that would be 12 plus 1 over 6, or 2 and 1 6. Again, I don't mind top-heavy fractions, so if you want to leave it as 13 over 6, I'm okay with that. Now, the other things that you need in order to find the volume of our sphere are these 3 formulas. You need to know the formula for the area of a circle, which is pi r squared. You need to know the formula for a cylinder, which is pi r squared times height. And you need to know the formula for a cone, which is 1/3 pi r squared times height. So let's keep those 3 formulas in mind. You guys can fill them out in the worksheet if you'd like, or just on a separate sheet of paper so that you guys can use it when working with the math. Now the next little bit is some history. We're going to be following what Archimedes did. He was a Greek mathematician who lived from 287 to 212 BC and discovered many principles, from theorems in calculus to displacement and density to an accurate calculation of the first 4 digits of pi. And Archimedes also discovered the volume of a sphere. What we're going to do is we're going to use what he discovered to find the formula on our own. And here's what he discovered. Archimedes took 3 objects. He had a sphere, a cone, and a cylinder. And he made sure they all had the same radius, and that they all had the exact same height. And for this, his height is 2r. You're going to want to really remember that. H equals 2r. Now, what we're going to do is see how he found that volume. What he did is he said, if he took the volume of a sphere and he added it to the volume of a cone, he actually ended up with the volume of a cylinder. So like he filled this with water and this with water, and he poured them together until he found, hey, look, it matched that volume of a cone, which is pretty phenomenal. And that comes down to the algebra behind it. So what I want you to do is see if you can use what I gave you today to try to find the volume of a sphere. And in order to do that, you're going to have to follow the steps on the worksheet that are attached on Classroom. And tomorrow what I'm going to do is I'm going to give you that volume of a sphere, and then I'm going to give you some practice problems so you can see how you did. That will be it for today. Don't be afraid to get this formula wrong. I more just want to see what you can do with the algebra that I gave you, and let you experiment a little bit with finding formulas for yourself rather than just getting them all the time from me. I hope you guys enjoy. Don't be afraid to ask me questions. Have a wonderful day. Oops, actually, one final note I want to add. While I do want you guys to experiment with this formula, to try it out, to solve it, please top off your attempts at about 10 minutes maybe. I'm not looking for you guys to spend an hour working on this. Like I said, I will give it to you tomorrow if you can't figure it out. But but give yourself a good 10 minutes to attempt this problem and see how close to an answer you can get. There is nothing to submit for today. Have a good one.